The pit was 30 feet deep. At the bottom, stone hammers, thousands of them, scattered across the floor like a crew had simply set them down at the end of a shift and never come back. And there, resting in a wooden cradle built specifically to hold it during extraction, was a 6,000-pound mass of pure copper. Still half embedded in the bedrock, the surface hammered into ridges and points by hands that had been working it free, inch by inch, for what must have been weeks. The work was unfinished. The tools were on the floor. The copper was still in the rock. When 19th-century miners found this pit on Michigan's Royale in the 1870s, they assumed they had stumbled on something recent, maybe a few hundred years old, the work of Native Americans who had abandoned the site and moved on. They carbon dated the oak cradle to establish an age for the record. It came back at approximately 1,400 BC, 3,000 years. That 6,000-pound mass of copper had been sitting in its wooden cradle for 3,000 years, waiting for miners who never returned. And that single pit was not an anomaly. On Royale alone, more than 1,000 pits just like it had been cut into the bedrock along the island's Minong Ridge. Hundreds more on the Keweenaw Peninsula across the lake. Some of the excavations were 37 feet deep and 70 feet long. Colossal diggings, as one 19th-century surveyor called them, made with river cobbles and fire, over a period so long it defies comprehension. And at roughly the same moment in history, around 1,200 BC, every single one of them went silent. The hammers went down, the work stopped, the miners left. They took an estimated 500,000 tons of copper with them. Nobody knows where it went. What you're about to hear is not a mystery in the fringe sense, not conspiracy, not lost civilization, not ancient aliens. It is a documented, peer-reviewed, genuinely unresolved archaeological problem. And when you understand the full scale of what happened on the shores of Lake Superior, before recorded history began, the question of who these people were, what they built, and where their copper went becomes one of the most extraordinary stories in American prehistory. Here is the fact that stops every researcher who encounters this material for the first time. The people who mined these pits were not Bronze Age people. They were not even close to Bronze Age. A 2021 study published in the journal Radiocarbon, led by geologist David Pompeani and archaeologist Michelle Beber, analyzed 53 radiocarbon dates from old copper culture, artifacts, and cross-referenced them with lake sediment cores showing traces of ancient mining pollution. Their conclusion rewrote the timeline entirely. The oldest reliably dated artifact, a 10-centimeter copper projectile point found near Eagle Lake in Wisconsin, finely shaped, engineered for hunting large game, is 8,500 years old. The culture that produced it, what archaeologists call the Old Copper Complex, emerged at least 9,500 years ago and peaked in intensity between 7,000 and 5,000 years before the present. 9,500 years ago, the Egyptian pyramids were built 4,500 years ago. Agriculture in the Fertile Crescent was just beginning when the people of the Western Great Lakes were developing the oldest complex metallurgy in the Western Hemisphere, and one of the oldest anywhere on Earth. They were hunter-gatherers, not settled, not agricultural, not organized into anything resembling a city or a state. And they were the world's first coppersmiths. The copper they worked is unlike anything found elsewhere. The Keweenaw Peninsula and Royale sit above the largest deposit of native copper on Earth. Not copper ore requiring smelting, but elemental metallic copper occurring in the rock in its pure form, sometimes as thin veins, sometimes as boulders weighing tens of thousands of pounds. You don't need a furnace to work it. You need knowledge, the knowledge to alternate hot and cold hammering, a technique called annealing to shape it without cracking it. Knowledge that took generations to develop and was, by any measure, technically sophisticated. They knew exactly what they had, and for thousands of years they took it. To understand the scale, you need a number other than 500,000 tons, a number that connects to something visible. The Cliff Mine, one of the most productive commercial copper operations in 19th century American history, opened on the Keweenaw Peninsula in the 1840s. It extracted 40 million tons of copper from its site. That site had been a prehistoric mine. The ancient workers had found the same deposit, with cobblestones, centuries before modern geology could locate it. Every major commercial copper mine opened on the Keweenaw Peninsula in the 1800s was opened directly on the footprint of a prehistoric pit. The ancient miners were better prospectors than anyone who came after them. And within 25 years of modern mining beginning, the Michigan State archaeologist would note, every physical record of the prehistoric diggings had been destroyed. Steam drills and dynamite obliterated what thousands of years of hand extraction had built. We know what was there only from the accounts of the first surveyors who arrived before the machinery did. Surveyors who described colossal diggings, mountains of waste rock, and pit after pit containing the stone hammers of people whose names we will never know. Here is where the story turns. Because you now know who these people were, the world's first coppersmiths, operating 9,500 years ago, in pits so numerous and so large that their total extraction dwarfs anything their era should have produced. The next question is the one that has driven researchers into genuinely contested territory for 2 centuries. With all of that copper, all of that extraction, all of those thousands of years of organized effort, what do we actually find in the archaeological record? The answer is almost nothing, and that absence is the real mystery. The old copper culture left artifacts. Wisconsin and Michigan museums together hold an estimated 20,000 copper objects recovered from burial sites across the Great Lakes region. Projectile points, knives, fish hooks, bracelets, celts. They are beautifully made. They confirm a culture of extraordinary technical skill and wide-ranging trade. Copper artifacts from this region have been found in burial mounds in Ohio, in ceremonial deposits in Indiana, in excavations across the Mississippi watershed, isotopically traced beyond dispute to the Lake Superior source. In Ohio's Hopewell burial mounds, built between 300 BC and 500 AD, archaeologists have found single copper objects weighing 38 pounds, ceremonial breastplates, headdress ornaments, effigy figures of birds and bears hammered into forms of startling precision. One of those breastplates traveled more than 500 miles from Lake Superior to its burial site in southern Ohio, carried by canoe, on foot, by relay trade. Because the people who buried their dead with it considered Lake Superior copper among the most valuable substances on Earth. That copper traveled 500 miles and was buried in a mound to stay there forever. And it still only accounts for a fraction of a percent of what the pits produced. Set 20,000 museum artifacts against 500,000 tons of extracted copper, and the ratio is so extreme that no amount of degradation, dispersal, or pioneer-era melting can close it. Researchers who have modeled this problem arrive at the same conclusion repeatedly. The documented North American archaeological record cannot absorb the quantity of copper that the pit counts, sediment records, and geological surveys indicate was removed. Not even close. The copper went somewhere that left no trace. And the operation that produced it ended with a completeness that is almost more disturbing than the absence itself. Around 1200 BC, the lead pollution in the lake sediment cores drops to pre-mining levels. Not gradually, abruptly. The hammers go down across hundreds of miles of Lake Superior shoreline at roughly the same time. The cradles are left in the pits. The work is left unfinished. It happens everywhere simultaneously, in a region too vast for a single local event to explain. The copper that was already extracted. Gone. The copper still in the rock, untouched for 3,000 years, until a 19th century miner's drill found it again. No campsites, no burials at the mine sites, no permanent structures of any kind near the pits. These are the details that researchers keep returning to, because they define the shape of this culture's absence. They came to Isle Royale, 50 miles across one of the most dangerous bodies of water in North America, in birchbark canoes. They mined for months. They left. The copper went south, and then it vanished from the record. The next chapter is the closest thing we have to an answer, and it comes not from a dig site, but from the bottom of a lake. The mine pits could be contaminated. Later, mining activity at the same sites destroyed the stratigraphic record that archaeologists rely on for dating. For a long time, this meant the true timeline of Lake Superior copper extraction was genuinely uncertain. The physical evidence had been bulldozed by the very industry that the ancient miners had, unknowingly, guided to the ore. David Pompiani solved this by going somewhere no bulldozer had reached. Small lakes adjacent to the ancient mines on Isle Royale and the Keweenaw Peninsula accumulate sediment in annual layers, geological equivalents of tree rings, each one a preserved snapshot of a single year's atmospheric conditions. When prehistoric miners heated copper-bearing rock with bonfires to crack it and free the metal, the process vaporized lead, a trace element naturally present alongside native copper in the regional geology. Those lead particles settled over the surrounding landscape and sank into the lake beds, where they were sealed under subsequent layers of sediment and preserved for thousands of years. Pompiani's team pulled sediment cores from Macargo Cove on Isle Royale and read the record directly. The lead enrichment in the cores, the chemical fingerprint of ancient mining activity, spiked precisely during the periods that matched the radiocarbon dates from the artifacts. It dropped abruptly at the end of each mining phase, including the final cessation around 1200 BC, with the precision of a switch being thrown. This is not interpretation. It is chemistry. The lake recorded what happened on the surface above it with the same indifference that it records a wildfire or a flood. The mining was real. The scale was real. The end was abrupt. And the sediment core cannot be argued with. What it can't tell you is why. Drought is the leading candidate. Paleoclimate proxies from the Great Lakes region show an extended dry period around 1200 BC that may have disrupted the logistical networks supporting seasonal mining expeditions to a remote island 50 miles from shore. Population shifts, changing social structures, a decline in the value of copper within the cultures that used it. All have been proposed, none confirmed. The lake remembers that it stopped. It doesn't remember why. Stand on Minong Ridge on Isle Royale today, and you are standing above the largest known pre-Columbian copper mine in North America. The island is a national park. The moose outnumber the visitors. The pits that the University of Michigan's 1929 survey described as becoming so dense they ran into each other are now overgrown, their edges softened by a century of forest growth, their depths still holding the occasional battered hammerstone that nobody has moved since the last ancient miner set it down. The island is 50 miles from the nearest Michigan shore. Getting there in a birch-bark canoe across Lake Superior, which builds ocean-scale storms in open water and runs cold enough to kill in minutes, required planning, skill, and a communal commitment to the work that modern observers find difficult to fully imagine. People made that crossing for thousands of years, in every viable season, because what was on the other side was worth it. And what was on the other side was the purest copper on Earth, in quantities that no other people anywhere in the world had access to at the same time. The old copper complex is the only known culture in human history to have developed complex metal technology prior to becoming a settled agricultural society. Everywhere else, metallurgy follows settlement. It follows surplus food production, population concentration, the division of labor that comes with a city. Not here. Here, mobile hunter-gatherers developed sophisticated annealing technique 9,500 years ago, maintained and refined it across millennia, and extracted copper at industrial scale, all while remaining seasonally mobile, leaving no permanent structures and operating through trade networks that stretched across half a continent. When the Hopewell people buried a 38-pound copper breastplate with their dead in Ohio 2,000 years after the mining peak, they were handling something that had already been through generations of exchange, something whose origin was distant enough to be legendary. The people who pulled it from the rock on Minong Ridge were not their ancestors in any direct sense. They were a much earlier chapter of a story that the Ohio burial mound only partially records. Most of that story is gone. The copper is gone. The people who took it were mobile enough, and the intervening millennia long enough, that the physical record they left is a handful of hammerstones, a set of isotope signatures in ceremonial objects scattered across the Midwest, and a sequence of lead measurements in lake sediment that prove, beyond any reasonable doubt, that something enormous happened here and then stopped. The pit is still there. The wooden cradle has been gone since the 1870s, its copper melted into commercial ingots and shipped east. But the copper stain at the bottom of the excavation, the trace of what was beaten free from the rock over weeks or months or years of effort, that's still there too, if you know where to look. 3,000 years of waiting, and the only evidence it left is a discoloration in the stone. Everything else was taken.